Hi, I am Konstantin, and today I will share with you some information about the design and schematics of the new V3 multi-battery charger tester. First, I will start with the V1, V2 and V3 comparison to understand the difference between them, and also after that I will demonstrate why V3 is faster than V1 and V2. Okay, let's start. So put it like that. So this is V1, this is V2, this is V3. Yeah. Okay. If you don't remember, V1 was constant load discharger, this is constant current discharger, this is constant current, and also can be, if you want, constant load, so will be both. A little presentation why it's better to be constant current than constant load. So when you put it an load on the battery, if you have this load, put it connected direct to the battery, first we'll start to, when the power is in top, we'll start to discharge with the maximum amps. So if you put one ohm resistor on constant load, first will be the battery will be discharged with 4.2 amps, and in the end will be discharged with 2.7 will be discharged with 2.7 amp. This is not the real fact. Usually in life, if you put a load, if you want to take 10 watts from a discharger, you put a load of 10 watts, will be discharged with 10 watts from start to begin to end. Also, the discharge curve, it's different if you discharge a cell with 1 amps or 4 amps. Yes, because usually the lithium-ion battery are designed to take it be about 1 amps in from one cell. Yeah. Okay. So also on constant load, because the load is different, the time will be bigger to test than constant current. So that is the difference between constant load, constant current. Let's talk. Let's put it here. The material we use it to build the charger. So first of one, let's put how many cells each will be handled. So this was 32 cells. Yes, cell. This was 30 cell, and this is 16 cell. If you look first time, this will be, you will say, tell me it's, oh, it's slower than the other two, but in fact the V3 is faster than V1 and V2. Yeah, so the V2 is a little bit faster than V1 because discharged with constant current, so the time will be shorter than constant load, and V3 is faster than V2, even have less battery. I will explain that when I will make a diagram with the schematics. So let's put it like that. So first, oh, it's not first, second, let's talk why I choose to why I have less battery with same computational power. Why each of that will use 2 Arduino Mega, yeah, 2 Mega controllers here, 2 also 2 Mega, 2 Mega here. So you'll tell me this is the same computer power, but Arduino Mega have only 60 analog pin for each Mega. Yeah, this is analog pin. Analog pin. Okay, so to make all the test, if you have 32 battery, you'll need about double amount of pins to make the test, because you need one set of pins to read the battery voltage, to know when to stop the charging, and also one same amount of pins to calculate the current or to read the current sensor if you use a current sensor. So if I have 32 cells here, I will need 64, yeah, here 64 analog pin. These with 30 cell I need 60 analog pin. Here I will need it 32. Yeah, okay, let's put it like that in first matter. To have 64 here, we need to use some mux. But even I use a mux, even in my first version, in version 2 I use mux to have more analog pin. What's the problem with the mux? When the power goes down, yeah, when usually it's not usually problem, but one on time for me was about two times when the power grid goes down and discharger working, this analog pin will discharge the battery through his inputs. But because this chipset don't handle so much current from the battery, the output will be damaged, will burn out. So after a power down, I have this problem. The mux was broken, so he need to be replaced. So that's why I don't use this analog mux to multiplex the analog reading, and I use directly the analog pins from the 2 Mega. You know, each Mega have 60 analog pins, for 2 I have 32 here. That way I have only 60 battery. Okay, so in version 1 I have to use I think will be 2, if I remember good, 2 mux, 2 of that, I don't know, 2 or 4, I don't remember in this moment. Here also 2 mux. Here I don't use this part, yeah. Okay, in first and second version I use this kind of relay board. He comes with already built it Arduino relay. This is a relay board with the optocoupleur to drive it, and also the transistor to drive it. It's one pack. This is one channel relay like this, has only 3 contacts, yeah. Okay, so it's same like this. So I will make this example with this little guy. So in version 1 and version 2 I will need it 16 relay, yeah, of that. Okay, this is version 1 and version 2, 60 or relay. Here also 60 on relay. In this version I use this kind of is dual channel relay, yeah, have 6 contacts here. It's like 2 relay of that in same case, yes, but it's cheaper this, okay, with 6. So here I have only 8 relay, yeah. Okay, also to drive this relay you have also need transistor and other thing and diodes like here, but it's same thing. If I buy it or I buy this, you'll see same thing. So this I have this relay. Okay, so for charging, this is one. To charging I have this little guy TP4056, yeah, charging lithium-ion charging module. In first 2 I use 16, yes, here I have 60 TP4056. Here I also have 60, 14, oh sorry, TP4056. Here I have only 8, yes, TP4056. So this is it's a common part, yes, it's also in this version, it's in all version. Yeah, this part it's in all version. Okay, another thing, here I have the P channel MOSFET, use it to start the charging. Yeah, in start and stop charging, here I have 60 of that. Oh sorry, this is only 30 cell, so this I have 15, sorry, 15 of that. Okay, this I have 16 EFR53 no 35 0 no 5305. This is P channel MOSFET. Here I have 15 EFR 5305. Here I have only 8 because I have 8 charging ports. ERF 5305. So this is also, it's a common part for all the project. Okay, this is the MOSFET for the discharging. Yeah, okay, this is ERLZ44N, so this will control the discharging. Here I have 16, yeah, of ERLZ44N. Here I have 15 ERLZ44N, but here in the first project I don't need it, but here I need the radiator. Yes, 50 a radiator. This heater sink, yes, for the, also here I need 8 of ERLZ45N, 8 ERLZ40 radiator. So this is also a common part. Okay, next, in all project I need power resistors. So here I have 16. I think it was 2 point, I don't remember the exact power resistor I used, but I think it was 2.7 ohm resistor. Here I have 60 or 2.7 ohm, and here I have double ohm. I have also 16 because I put it 2 in parallel because I need to have more discharge power. 2.7. So this is also a common part. Okay, this is not this is the operational amplifier. Use it to can control the constant current discharge here. So was not in the first, let's put it like that. So this is common part. So this was in first project, this I used in version 2. So I have 15 of here, also 15 here of operational amplifier. I don't know now what I do, what kind of amplifier, but I can look in the other video. So I have this, and also I have the RC filter, yeah, operational amplifier and RC filter for that. This is only in this project, yeah, this is in these two projects. Okay, so in last project here we have two more parts. We have the current sensor, use it to read the current for in charging. Yes, this is very nice because you can see also the charging capacity, how much current you put it in the battery. I have 8 of current sensor ACG 712 5 amps current sensor. So this is only for this part, and also I have the temperature sensor for each cell. 60 on DS80S20 temperature sensor. This is very important because I can track the temperature of any cell if it's any problem. Okay, so if you look, if you look here, it's less parts, only these are in fact the new parts I use it. Yes, okay, you don't find this in another project, but you don't have these parts in this project. Don't have this, and don't have the operational amplifier here and DC filter. You don't have also that, and the quantity of the quantity, it's less of that, it's half. In fact, if you use everything, it's half. Only the resistor, it's about same, the power resistor, but the rest it's half. So are less parts here, and I think the ACC and DC will be about same prices with the muxes. I don't know if I use 2 muxes or 4 muxes, I'm not sure. I think I use only 2 on the other version. I don't know if I do use only 2 analog mux or more, but I have 2 muxes here, and also the operational amplifier here, which also goes down. So this is the difference between version 1, version 2 and version 3. I will explain you now. I will make you some graph to understand why version 2 version 3 it's faster than version 1 and version 2.